Hi, chemistry students. I just wanted to highlight the book and also show you where we're at in the book. It's in chapter 2, and the chapter 2 folder is inside the book folder, but I did link it into the chapters, into this folder that you're doing this week. But to visually show you where we're at, this is the chemistry book. If you like to get a copy, please let me know. We can meet somewhere near the building to pick you up a copy. But we're in chapter 2, and I wanted to highlight the chapter. This is the chapter here. Analyzing data is their title, but we're right inside the very first section. So section 1 is where we're going. We're actually talking about pages 32. This is page 32 here to about 40. I don't know if it's quite 40. There's a little bit about density we're not doing quite yet. So there's some parts that we aren't doing, but we're going to go all the way up to scientific notation, which is 41 to 43. So that's what we're going to be this week. Again, in this little section on density, we're not doing to the end of the unit, this little section on density, but I wanted to get you into some of these units here. Okay, so the gist of this unit is to talk about where we get the metric system figured out, or the actual name for the metric system. And we have this table of base units that we're going to go over. Okay, and base units is basically a defined unit that is in a system of measurement that is based on an object or an event. So it's not really, it's like there's no other connection to it. They're like these main 7 units of the metric system right here. It's on page 33. It just is the main unit. And technically, a base unit can be measured directly. You don't derive it. You don't have to calculate it. It has to have some type of tool to measure it with. So each of these have an actual kind of tool that's been made to measure it. And then we're going to go into the metric prefixes here. And you want to be familiar with this order. We're going to cover giga, mega, kilo. The base unit is right here, like a meter, liter, gram. We're going to use deci, centi, milli, micro, nano, and pico. So this vast set of units we're going to be using and we quizzing on. And since we're not in the classroom, you're going to be able to use your resources on the order. As we get back into the classroom and we're going to be taking live tests at that time, you're going to have to know this order, these prefixes, and the power. But right now, you're good to just use it as a resource and not have to have it memorized. Okay, but there are some really good examples here, not so much in this first section, but later in the week when we get into scientific notation, these examples are really good. I'm going to probably assign these or something similar to it, but these examples in the book are really good. Okay, so let's go ahead and get into the notes that I wanted to go over, and that's what this is. You can just get your own note paper, and write this down. It's really a lot of white space, so I figured you could just write it on your own note paper. Okay, so the biggest thing about the unit is what we're calling the metric system. And so this is the SI system is actually a name for the metric system. And the reason why it's got SI is because it has a French origin. It's got a French origin. Apparently, it has to do with even Napoleon when he was doing the battles in the 1800s, 1700s. I forget really what time frame he was the leader of France, but he wanted to make everything uniform around the European area. So he actually set this up, or influenced the country of France to set this up. So it actually is called the SI for the French way of saying System International backwards, or actually calling it the International System of Units. Okay, but in the French way of saying it, you're going to be putting the word international after the word system. And so to actually show it in the book over here, you actually can see it labeled the way the French are doing it. because the French had the basic emphasis to starting the metric system at one time, and it had a lot to do with Napoleon's influence. So the units that we're going to use a lot, and these are going to be the first 5, is going to be with time, it's going to be length, mass, temperature, which are ones you're probably all used to. I'm sure you've seen all these, talked about them a lot, and other units too that you've used in your previous science classes. But the other one that you haven't ever heard of is called the mole unit. And the mole unit is a unit for the amount of substance, actually. We're going to actually put amount of substance here, and we're going to call this a mole unit, okay? And then the other 2 aren't as important in terms of our year in the chemistry here, but they're going to be an electric current, and candela, or light intensity. Okay, so these 2 aren't as important. These 2 aren't as important. These 5 are the ones I want you to know. And the units that it goes with is going to be second, and they're going to use a little letter S, and you're used to that one. I mean, we use seconds all the time. And then length is going to be in the meter. I'm sure you've seen and used a meter stick in your previous science classes. We're going to use a little m for meter. Mass is actually going to be a larger unit than you would think it would be. You're probably going to tell me it's gram, but it's actually kilogram. Okay, so you have to remember it's going to be the kilogram as the base unit. And the reason why is a gram is a really tiny, tiny amount. This is about basically 1,000 grams, and it's about 450 of them is a pound. So this is about approximately right around 2 pounds. And so 2 pounds is actually, there is actually a 2 pound or a kilogram standard in France in an airtight container. And those kilogram standards is what the actual system is saying is the base unit. You're going to use kilogram and not gram. And every kilogram is approximately 2 pounds. That's a little phrase to say pounds, LBS. So just to give you an idea what that is, our weight, our mass in pounds is usually half as much, it's about half as much. So if you're about 150 pounds, you're about 75, 80 kilograms. And then temperature. We've used Fahrenheit a lot here in America. They've used Celsius in all the European countries. But the actual best unit for the metric system that can be used in all other type conversions is the Kelvin. Kelvin starts at 0, where the other 2 scales do not. So we're going to remember that we're going to use kilogram with the kg and Kelvin for the temperature. And then the last one of the 5 you're going to have to worry about is the mole unit. A mole unit is not a furry creature. This is the unit that chemists use to relate the amount of substance, and it has a lot to do with the masses on the periodic table for each of the elements that will make compounds. So we'll get and use the mole a lot. It could be shortened for MOL. It's pretty much not even needed to be shortened. Like these are pretty much easy because this is second, which is S. Meter is an M. Kilogram, kg, Kelvin is a capital K, and the mole really doesn't even need to be shortened. It's MOLE. Again, later in the year, especially in second semester, we're going to use a mole quite a lot. And if we were together in the classroom, I'd have a lot more visuals to help you understand it. But as we ever use the mole, and we will use it more later, I will be more visual with it. Now, the electric current is the amp, the ampere, for AMP. They use that for electricity, and then the candela, which is the unit for light. And you can actually read candelas on a light bulb. I don't know how common it is. I've seen them. I've also seen them with lumens. but those are the units. I definitely want you to be knowing these 5 for sure. These 5 definitely mark down that you know those, okay? Other metric units that are SI units, SI means the metric system, SI means the metric system, is other ones could be the liter. We could use liters. We could be using other units later in the year. We're going to talk about gas pressure, and that is a Pascal. We could be using the unit joule for heat instead of like a BTU. That's a British thermal unit. Joule is a metric unit that we'd use. And we're going to have some volume units and temperature units later. I'm not going to worry about them right now. But I wanted to let you know that base units are units that are directly measured with equipment, with some type of equipment. These are got to have some type of equipment to measure the gram, meter, second, Kelvin. They have to have some type of equipment or some type of instrument. So these are directly measured, are base units, and then derived units are units that you have to calculate. These are units where you use base units to calculate into a derived unit. And a good example would be speed, okay? So if you're going to do speed, that's going to be a length divided by time. And since you have to calculate it, length divided by time, that's going to give you speed. Speed is an example of a derived unit. Density is mass over volume. Mass over volume, that equals density. You have to calculate to get density. You have to calculate to get speed. That's what gives you a derived unit. So a base unit is directly measured, like these 5 here I'm talking about, or a base unit when you actually put them together and to make a derived unit, okay? So let's actually get into the metric scale, okay? So I'm going to flip my page around. We have this metric scale, and I've actually got them on the top of your homework sheets. These are the homeworks you're going to be doing. Metric practice, which is like number 1 on the list. This is metric practice. You guys can make a copy. You don't necessarily have to turn these in. So you could just get a copy and you can do the work on another sheet of paper. You could print these out. You could type in the answers, but honestly, you're not going to be turning this in, but they're visuals to help you. But you can use this table. So I honestly think you should just print this out just for the sake of having this table. And then also I have another version, practice number 2. Again, these are just lots of practice. I will be posting the key probably by Tuesday morning, having a key ready. I already have them ready, but it depends on whether I can get it posted into the folder. But this has the scale that we're talking about that I'm trying to help you understand. So these are just 2 sets of homeworks to get you ready for a big chunk of the quiz that we're having on Friday. So what I'm going to do is go to another handout here just because it's a better visual. And let me get here away from the book and try to show you how to do metric conversions, okay? So metric conversions, let me try to get where it's not glaring, okay, is that we're going to have giga here. It's really large. This is really large units. So if you want to get a sheet of paper out, a basic white sheet of paper out and put giga down, then you want to have 2 spaces away from mega, 2 spaces away from kilo. Then there's hecta and deca. I'm not going to really use them on my worksheets, but I know you've seen that before in previous courses with science teachers in junior high. So it's a lot like this scale. We have giga, do 2 lines to mega, 2 lines to kilo. Here's hecta and deca. We're not going to use it very often, so I didn't even put them in my line. Then we get to the base unit, deci, centi, milli, 2 lines then to micro, 2 lines to nano, 2 more lines to pico. So you could use this number line. I'm just trying to use this as a bigger visual to help you understand the conversions. So these are really large units, really large units.